In this last example of the lesson, we're going to go over limits with infinity. So we're talking about vertical asymptotes and what happens as we approach a vertical asymptote for a certain value of x, what happens to the behavior of the graph. Looking at this first graph on the left, we have the function 1 over x minus a, where a is any constant, and that is being raised to the power of n. So if n is an odd positive integer, meaning if the power is a 3 or a 5 or a 7, this is going to be the basic shape of the graph, and your asymptote is at the value x equals a, which is shown with the dashed orange line. So if I'm approaching from the left, if I'm approaching a from the left, I'm decreasing without bound. So I would describe this vertical asymptote using limit, saying the limit as x approaches the value of a coming from the left of the function f of x, I would describe that as the behavior decreasing without bound, and I would label it with a negative infinity because we're decreasing. The limit doesn't exist because it's not approaching a specific value, but we can describe the behavior by labeling it with a negative infinity. Now, coming from the right, looking at the same graph, but approaching a from the right, we're approaching that vertical asymptote and we're increasing without bound. So I would describe this as the limit as x approaches a from the right-hand side of the function f of x. I would describe that as positive infinity. Again, making the point that that doesn't mean that the limit exists, but we can describe the behavior of the graph with a positive infinity as x approaches that value of a from the right. Now, if we have an even integer, now we're looking at the same function, but the power of n is going to be an even positive integer. So like 2, 4, 6. Then the behavior of the graph is going to look like this picture that's on the right-hand side, where both behaviors coming from each side approaching a, they're both going up. So coming from the left and going up, coming from the right and going up, the behavior is the same. So I can write that the limit as x approaches a coming from the left of our function, and this is specifically when we have an even positive integer for n, we're going to describe that as positive infinity. Coming from the right, I would also describe that as positive infinity because coming from the left and the right, it's both increasing without bound. So I can describe that with the two-sided limit without the sign positive or negative of the function as positive infinity because the behavior is the same. So we can describe the behavior of a graph surrounding a vertical asymptote using limits.